Hello and welcome to the last office hours of 2024 of the year. My name is John Kowalski. I'm part of the marketing team here, here as always. So welcome. Today's presentation, I guess it's not really much of a presentation, is more of a discussion. We do this at the end of every year, kind of a full open forum, color and appearance, anything goes. If you have any questions, comments, any challenges you're facing at one of your own facilities, just drop it in the chat and we'll get right to it. We got our technical expert, application specialist, Noah Morgan, on the line, as well as a couple of our field marketing people as well. So here to answer your questions and welcome as we usher in the holiday season here. How about that? Hey, Noah.
Hey, how's it going? Good to be here.
Good. Yeah, we made it to the end of the year. How about that?
Yeah, we did.
And you may have seen too the invite for this. We have a packed program for next year. Feel free to register for any and all of those coming up. We will be adding additional programs throughout the year too. So just watch those invites. Noah, you want to start us off here?
Yeah, sure thing. So, like you mentioned, today there's no real presentation, but we're going to go over, basically any questions that people have in your industry about color, appearance. We can even go into physical tests.
Yeah.
Yep. This could be for your own color program. This could be for, weird phenomenon that you're seeing with your samples. So just think about questions related to your field when we're talking about color and appearance. And once you think about those questions, you can put them in the chat and we can talk about it. It'd be pretty cool.
Sounds good. Sounds good. I have a bunch of questions that I've assembled kind of throughout the year too that I can throw out, and Noah and I will just have a discussion about that. Keep loading them in. We got one in already. Christina, thank you. And she's asking, is it feasible to use only data collected with the BYK-mac eye to make color position evaluations without using visual assessments? Is the BYK-mac eye capable of capturing the nuances only achieved through visual judgment?
Great question.
Yeah.
So from what it sounds like, you're asking if you could essentially just use the BYK-mac eye to take out your visual assessments altogether, which you can do, absolutely. So, the BYK-mac measures multiple angles of color, and so it's needed when you're talking about automotive colors or metallic effect colors because they flop, right? The color changes as you change your angle, and so the BYK-mac is able to capture the color changing as you change those angles. Hold that data. That way you can compare and contrast other standards or samples, but it also captures the sparkle, the sparkle that's occurring in that material. So it captures at different angles, and you can use those different angles for different evaluations. But you could, in fact, use just the BYK-mac eye as your color control, get away from visual assessments. But we always like to go over visual assessments because in some cases, you could have an error in where somebody took a measurement. It could be a bad measurement, and you could miss important things that are happening on your product. So we always urge to do both. Let's say you take a measurement on every product, but you don't necessarily look at every product. You could look at maybe every 100th product that comes off the line, just to make sure everything's matching visually as well. Because we want to rely on numbers, but at the same time, it's important to see the whole picture of what's going on, because there might be a few things that get missed, let's say in between measurement spots or some other issue along the line there.
Yep. Good point. Good point. So yeah, we had our sales meeting last week, and we did some of these uh, I guess assessments just by looking at the raw data, and it's like, all right, what color is this? So we definitely can do that, but as Noel mentioned, the visual analysis is also part of a kind of a recommended program that we subscribe to. Other questions, keep them in, keep coming in. On that note, Noah, color program, are there other key things that people need to, I guess, prescribe to keep consistent, line to line, shift to shift, plant to plant, when they're taking measurements, so there are true apples to apples comparisons?
Yeah, sure thing. So, with any type of measurement or metric, you always want to be consistent with how you're taking the measurements, all the different variables that go into it. Because at the end of the day, when you compare data, you want your data to be comparable. You don't want data that's completely different from what you're trying to compare to. And with that, there's some things that you could follow. For the BYK-mac itself, again, that's our multi-angle spectrophotometer. And it's important to keep the orientation of that the same when you're measuring different samples and comparing, because that instrument measures with a single light that shines from a single direction, meaning if I change the direction that I have that light coming from, it could throw off all of my data. And that's just due to some different things with the material itself. Texture can play a role in that. How the colors flopping can play a role in that. So it's always important for that specific instrument to keep it in the same orientation, because directionality does matter for that type of device. When it comes to other things, though, like our Spectra 2 guides or solid color instruments, they don't necessarily matter which orientation you have them, because they use circumferential lighting, meaning the light comes from all sides. So you can have it, one way, you can rotate it 90 degrees and take another measurement, and you should be getting the same values either way. But with just the BYK-mac, you have to keep in mind that it's directional. So you could get different results depending on which orientation you have it. So keeping that consistent is always good. As far as what you're measuring with, there's a lot of settings in spectrophotometers, like the light source you're using, the calculation that you're using to get your difference values, the scales that you're using. You always want to keep those consistent too. So it's always important to at least maybe write that down somewhere, the settings that you use, all the parameters that you're going to use for color testing. That way, if something were to happen, you can always refer back to somewhere and know exactly what you do for your testing.
Yep, good. And then just make sure, your instruments are all set to the same settings, and then personnel is trained on how to handle the instrumentation. So specifically with the BYK-mac eye, so they are doing it consistently across plants, across shifts. So then you get that apples to apples comparison. I think we run into that a lot, and it's just being consistent and locking down the standards and how you're taking those measurements. So thanks, Noah. Another question here from Luis. I'd like to compare the color of an NCS swatch on paper with my product. The product is a 6mm extra clear with acid etching on surface 1 and ceramic frit in position 2.
All right. That sounds interesting. From what I'm getting from that, you're trying to measure a sample, the color of a sample with a piece of glass on top of that. Is that right?
Luis, I just unlocked your microphone. You're able to unmute yourself if you'd like to chime in and elaborate a little more about what you're trying to do. And you should be able to do that in the upper right-hand corner. You should see a microphone in a red circle. If you just click that, you'll unmute yourself. Give him a moment here, but yeah, yeah, an NCS. It looks like NCS color swatch. And match it. So would you take Noah? Would you take a measurement of that swatch to get the color values, the curves, and then use that as your standard, and then compare it against the product as a sample? Is that how you'd
Yeah.
approach that?
Yes. I mean, you could, if you're trying to figure out what the effect is for that glass on top of it, to
Yeah,
see, how that plays a role into what the color is or how you see the color through that.
yeah,
That could be something you would do for sure.
yeah. He
And
said
take
the color.
standard of your swatch. Go ahead.
He just wrote, maybe he hasn't having some microphone problems, but he just wrote again. The color is the ceramic frit baked on the glass. So
Yeah,
it's Oh, there you are. Hey, Luis.
yeah, hello. Yeah,
Welcome. Tell us about your challenge.
yeah, so yeah, that has been a long challenge. Yeah, I'm measuring through glass. So the
Okay.
ceramic frit is a ceramic ink that we apply on the back of the acid etch, and it's easy to measure it on the ceramic side because you have a direct contact with the color. But when it's spaced 6 millimeter away on extra clear glass, then there's other factor. We get totally different results. Although the color seems right, but when you try to compare it, I mean, we don't get the same measurements at all.
Mm. Yeah, that can be a little tricky. Just due to the way the technology is for spectrophotometers, what it's doing is it's essentially sending light through or down into something and
Yeah,
then recording the light that gets reflected back off. So I think no matter what, you might inherently have an issue with the glass affecting that reflection and that light that's being passed down to it in some way. I think what John mentioned, which was making a standard on the actual color itself, and then let's say take sample measurements through the glass, getting the color through the glass, and then you can see how much that glass affects that color reading. I don't know if it's going to be possible to get an absolute measurement for that through the glass, but you may be stuck with just relative measurements and knowing how much influence that glass has on that color. You can factor that into those relative measurements and essentially get a rough idea or a trend over time
yeah,
of how that color is being affected by that glass.
yeah.
Now,
That's what we've been doing. Yes, because
yeah.
we see the shift, but I'd like to have something more. Eh, I was thinking about a color luminance meter. Would that do the job?
I don't know. That's a great question.
You don't do that.
Well,
I don't think so.
yeah. I was going to say, we can follow up with you directly and maybe get some samples. And no, I'm volunteering you to run
Uh,
some tests in the lab.
yeah,
to come up with a solution for you if that would work.
yeah, maybe. I'm using your equipment, but just
Okay.
the Haze meter myself,
Yes.
Hmm.
and I've been using that for a few times. Yes, and discovering how it works and everything. It's a great machine.
Yeah.
Uh,
But
but
it's
then
just, yeah,
I
just
have other problems to
yeah,
solve.
yeah, yeah. Yeah, it sounds like just locking down a standard process
Yeah.
that you can get that consistent data.
Okay.
So we'll have someone reach out to you directly and solve this with you.
Good.
That would be great. We appreciate it.
Super. Thank you.
Thank you.
I'm out.
All right, you're out.
Yep. Take care.
All right. Yeah. So that's. I mean, this is the stuff that we're here for. If anyone else, you're experiencing something that's a bit of a challenge, let's talk through it. If we can't solve it here on the phone call, we can definitely get in touch with you after the fact and run some tests with you. I know this is a broad question, Noah. We talked about the process of how to hold the instrumentation and to be consistent across the board. But are there other kind of key tips and tricks that you're finding you get a lot of calls of and assist a lot of customers with that maybe you could share with us here?
Yes, good question. We cover so many different instruments in this line of work.
Yeah.
Let's say one of them would be curvature. So curvature, a lot of things out there have curvature. And when you're using light to measure, certain aspects of these things, curvature can play a role in scattering that light. And sometimes it, can create issues where you're not getting true values of what you would expect to. A great example is gloss. Gloss is a very simple measurement. You're essentially sending light from one side, and then it's being reflected off the surface and being picked up on another side. And a lot of things can go wrong if you start adding, heavy texture or curvature to that, because you're no longer having a flat surface for that light to reflect off of. Now you're adding more variables to it. And so a lot of times when you have curvature, similar to what this last application sounded like, you get into problems where you don't necessarily get absolute values every time. And so it's important that if you know that you can't get an absolute value, that you can at least set up procedures to where you can get relative values that can be comparable to each other. In some cases, this would be something like setting up a jig. For some of our instruments, for some of our instruments, we have the option to purchase or even 3D design a jig that can hold your instrument on your specific parts the same way every time in the same spot. These are always nice because you can get the same measurements. If you're always going to have everything else locked down in the same spot, you can be assured that what you're going to be measuring can be comparable to one another. Especially in situations with curvature, when you can't always know that what you're getting is exactly the true value just because of the inherent scattering that happens. So just some things around that, customize your own process in order to make it as best as it can be for your specific material, I would say, is a big one.
Yeah, I mean, we've mentioned, or you mentioned, the jigs kind of throughout the year, and I always forget those. But that's a great way to just, like you said, lock down that process so that the instrument is held or the sample is held in the exact same position every single time. So good on you bringing that one up there, Mr. Noah.
Not a problem.
Yeah. Okay. Keep those questions coming in. Looking through some questions that we've gotten throughout the year. How does gloss and texture play into color measurement?
Ooh, great question. Great question. So to answer that, think about, let me think of a good example here. If you're looking at, let's say, a magazine, right? Your magazine's going to have a lot of colors depending on what you're looking at. What you can see, magazines are typically very smooth. So it's going to have, pretty high gloss values, but what that's going to affect is the color. And because you have a very smooth object, that color is going to be very, very contrasty, very deep, vibrant. But if you start to add texture to that, now you kind of have to shift gears and not think in line of as a magazine. But if you add texture to that, it slowly starts to add in these little micro textures that scatter light. And so what you would end up seeing visually is that the surface gets more dull as more light is scattering in different directions. And so it's not going to be as clear as a contrast, if that makes sense, if you're following with that. There's different examples there.
Yeah, definitely. No, thank you. Question from Joel here. Would I have the same issue like measuring through glass when you apply more than one layer of clear coat?
That's a good question. Not so much. When you're talking about layers of clear coat, they're such small layers that it doesn't really take into account or doesn't affect it that much to that degree. It's different from 50 microns of clear coat rather than, an inch or 3 inches of glass, let's say. For the instrument, it's not that big of a deal. What you're happening is the light's coming into being absorbed into some of that coating and then being reflected from, the other parts of the coating, like the pigments. If it's a metallic color, it's got the flake in there that's reflecting the light. So you have a lot of things happening in there, but it's not going to affect the color reading significantly enough to where you would see a difference.
Okay, good. Thanks, Noah. Let's see. What sparkle angles are most important in the paint process?
My favorite question.
I know. I have that highlighted always.
So as far as the sparkle angle, this would be with the BYK-mac or the BYK-mac eye. What's nice, I think I mentioned earlier, it measures multiple angles, so you can really understand how a color is traveling, as specifically effect colors. As you move around a car or any other, effect color that you have out there, as you move around it, it's going to change colors depending on the angle you're looking. So the BYK-mac can measure the color changing in those angles, but it also measures sparkle, and it measures at 15, 75, and I believe 25 degrees or 45 degrees. But what's nice about that is you can then look at those specific angles and understand what's happening either in your process or in your formulation. Specifically the 15-degree angle, you can see when you have the data there, if all of the sparkles are sparkling the same on one of the angles, or let's say you're looking at the 15-degree angle and you have some sparkling and you have in some area but little sparkling in some area, you can find out if you have the same paint formulation, because you can look at those values and directly compare that to the metallic flake, if they're all sitting flat or if there's different degrees with sparkleness, that would tell you if there's different shapes and sizes that are used. So it could tell you if you have a completely different paint system altogether. And then you can use the 75-degree angle to understand if all of those flakes are laying flat. If you can imagine, if you have all of these sparkle intensity, if the sparkle intensity is very high at one angle, then you could be assured that all of your flakes laying flat. But if you see that you have different degrees at different angles, or they're all pretty much the same at every angle, that'd be a good indication that your flakes laying in different paths. It's not all flat. And so when you look at that across the different angles, you're getting different degrees of sparkleness depending on the angle. So the data for a lot of things, which is nice.
Yeah, I mean, you can look at the angle of it, but can you also use that BYK-mac eye to look at particle shape and the size of that in addition to the angle?
Yeah, so it gets really deep too, especially in the formulation side. But you can use it. We even have a special software called Flake Analyzer, and you can get really deep into looking at the characteristics of the sparkle, looking at the shapes and the sizes, like I mentioned, to see, do you have the same formulation? Are the flakes different? Are they the same? How are they different? Looking at mica versus Zrelix, you can see brightness differences. One's going to sparkle more than the other. So you can get really deep into it with this other software that we have. And it also takes pictures of the sample. It takes a picture of the brightness of all the sparkle reflecting back, and then you can relate that to the actual material and so on.
Sounds good. And that's not me drinking. That's my dog here. So if you can hear that, it's always an adventure working from home. Wouldn't have it any other way, though. Okay, moving on here. Yeah, keep those questions coming in. From our webinar on gloss theory and applications, can you explain the three main geometries, 20 degree, 60, and 85 degree, used in gloss measurement, and when each would be most appropriate?
Sure. So when it comes to gloss, you have three angles that are not 3 angles. You have 5 angles normally altogether, but only 3 of them are the normal ones. Typically, you don't have 45 or 75. Those are really only for special applications. For example, the paper industry, I believe, uses 45. The ink industry, I think, uses 75. But you also have the regular angles. You have 25, 40, or you have 20 degrees, you have 60 degrees, and you have 85 degrees. Your 20 degrees are typically more for high gloss surfaces. You're going to get a good correlation or visual and match to high gloss surfaces with 20 degree. 60 degrees is mainly for semi-gloss. So if you're measuring semi-gloss finishes, the 60-degree angle will give you values that match the best to what you're visually seeing. And then lastly, with the 85-degree angle, when you're looking at that, it's a pretty flat angle on your sample. And so that's going to give you really good correlation for very low gloss surfaces. Typically, it's 1 to 10 gloss units is you're going to want. So think about, you take a measure with the 60-degree angle, and if it's within 1 to 10 units, you're going to want to use the 85-degree angle to give you values that compare the best to what you're visually seeing. If it's between 0 and 70 gloss units, you're going to want to use the 6-degree angle. And if it's higher than 70 gloss units, you're going to want to use the 20-degree angle. And that'll give you the best comparison to what you're visually seeing.
Nice. Joel's asking, what software is that?
So I think referring to the flake analyzer software.
Yeah.
So if you have a BYK-mac I, it's one of our higher end models, and I think it's the BYK-mac I Pro, and that specific model comes with another software called Flake Analyzer that you can use for really good quality control and also research on flake, just because it can go so deep into understanding different data sets. But
cool.
Like I said, it's only working with the Pro model for the BYK-mac I.
Yep, good. Another question here. My company produces packaging film, often for the food industry. We typically measure gloss on a transparent film that's 3 mil thick or less. What's your recommendations?
Yeah, great question. So what you have to first understand is that because you're measuring transparent material with the gloss meter, you're going to not get a true gloss value because you're losing some of that light that's getting absorbed and reflecting off of whatever's underneath of that material. So again, this has to do with keeping everything consistent. Unless, I would recommend putting some type of matte black background under it. What that's going to do is it's going to drastically limit how much the substrate or what you have underneath that material is going to play a role into the gloss. So you can imagine if it's a matte black background, it's going to have very low gloss, and so it's not going to change the values as much. That would be the first start. The second thing would really actually it would just be that, getting a consistent background and then staying with that background the whole time. If you start to have different thicknesses of material, I would suggest, keeping it separate. So only comparing samples of similar thicknesses to each other. Once you have different thicknesses, the light's traveling through that transparent material differently.
Yeah.
You're really getting just a reflection off the surface of it, and then you're getting the light that's scattering throughout the sample, and eventually it's going to dissipate, and that's also some of the value of gloss that you'll be getting. So you're not truly getting a purely absolute value, you're getting more of a relative value, and at that point you would want to keep everything consistent, and if something changes, to at least write that down somewhere, put a comment down so what changed here was the thickness of this material, because that could explain why the data looks slightly different than the other things, if that makes sense.
Yeah, that's good. Good. Thank you. Stephanie's question about geometry of spectro. Which geometry is most correlated with visual evaluation? 45-0 or D8 sphere? Considering surface texture, which can have an effect on color perception?
Yes, great question.
Yeah.
The geometry that matches your visual the best will be 45-0. It's designed in a way to essentially mimic exactly what we see with our human eyes. But what it does is, you have a sensor usually at 0, and your light comes in at 45 degrees. And so what it's doing is it's making it so where the sensor is not picking up the pure light that gets reflected back. I use the example of a magazine again, where if you want to read the words on a magazine, you don't want to hold it in a way to where all the light's reflecting back into your eyes. And that's the same way that the spectrophotometer works. So 45-0 would be the best instrument for, correlating to our visual analysis or visual evaluation. When you take into account surface texture, if you have different surface textures of that material or your product and you take measurements, if those surface structures cause the material to look different visually to you, then the instrument's going to pick that up and state that. If you had a D8 sphere instrument, you could take measurements on all of the, let's say, a variety of samples that have different, different surface textures. That one looks matte, one looks glossy, one looks semi-glossy, but they're all the same exact color. The sphere instrument will tell you that they're all exactly the same because it doesn't take into account that surface texture. But the 45-0 will tell you that they're all different because it takes into account that surface structure. Hope that answers your question.
Yeah. Does that help, Stephanie? Or if you need more clarification, just drop a note. Or ping the chat and ask to be unlocked. I can unlock your microphone too if you'd like to elaborate more. Let's see, what's next? Transmission, haze, and clarity. What factors affect this, Noah? And how does someone analyze the data?
Yeah, so really, it could be anything that affects that. It could be, anything from a smudge on a piece of glass. It could be, internal scatters. Maybe it wasn't dispersed enough during the manufacturing of this material. If the surface is smooth or if it's rough, any additives that are in there could affect it as well. Yeah, there's really a variety of different things that could affect it.
Okay. How would someone move ahead to analyze the data?
So yeah, we got a couple of options with that.
Okay.
First you have your haziness, and so that's really like if you could picture like a milky look when you look through an object, how hazy it is. You have clarity. So clarity is how clear an object is. It is dependent on distance. And so if you have an object, let's say right behind a piece of glass, it's going to look real clear. But as you get it further and further away from that glass, it's going to get blurrier and blurrier. So you have that effect. And then lastly, you have transmission. So transmission is just how much light is able to go from one side of that material and then clearly be picked up on the other side of that material. So that's related to scattering effects. Obviously, if you send light through something and it scatters, you're going to have a lower transmission. So our Haze guard, which is the instrument that measures all of these, is great for this. So you can take your material, whether it's a very thin film like a plastic wrap, to a piece of glass, to really any type of transparent or clear material. You can get all three of these values. You can get your haze, your clarity, and your transmission. So I think that's a pretty good instrument. If you're looking for something like food packaging or lenses, optics, anything along the lines of that, Haze guard would be a great piece of equipment.
Nice, nice. And we talked about haze, we talked about gloss, we've talked about effect colors. How about texture? What do we got for measuring texture, grain?
Yeah, so we have our lovely instrument called the Spectra 2 Profiler.
That was a perfect setup, wasn't it?
Yeah, it was. It was an alley-oop. But what this Spectra 2 Profiler, what it essentially does is it has a lot of these different measuring tools inside of it. So it does color, gloss, and texture. And what's nice about that is you can not only quality control your gloss and your color, but you can also control your grain. And by grain, I mean, like the leather pattern that you would have on a car seat or car upholstery, or even a basketball. What it's looking for is the specific size of that grain, the height of the grain, the distance from each grain to another piece of grain, the reflectivity of the grain, how reflective is it? Is it more of there's a lot of microtexture going on? Is it a little bit of microtexture going on? So you can really get a full quality analysis of what your specific material or product is and what it has. So you can control, a lot of quality aspects of it.
Yeah, nice, nice. I just dropped in the. That looks a little funky. Let's try this again. 2 links in the. Wow, something's going on here with me pasting things. We've had some issues with this chat functionality. So anyway, all I'm saying is go to bicinstruments.com, bic-instruments.com, and specifically check out the knowledge area. It's a knowledge library where we put all of our technical articles, case studies, things like that. Lots of great information there. That's immediately at your fingertips. And let's see. Well, we're waiting for a couple more questions to come in. I see those new products sitting there on the screen.
Yeah, got some new stuff here.
Yeah, PELT Cone Plate.
Yeah, so we recently joined forces with Imaginate, who makes the PELT gauge. The PELT gauge, if you're unfamiliar, it is an ultrasonic film thickness gauge, but not just any ultrasonic film thickness gauge. This is one of the most accurate ones that's available on the market, and just simply due to the current technology too. But basically what it does is you can get a foolproof, straight answer of not only total film build for any type of substrate, but also individual layer thickness. So you can get specific layer thickness for your base coat, your primer, your clear coat, then your total film build, and it can go down to some pretty small ranges. I want to say for one of the very high frequency transducers that they sell, I think it goes all the way down to 6 microns. So very, very accurate piece of equipment there.
Mm-hmm.
I see we also have our Cone and Plate Viscometer. So that is one of our very, very new instruments here. Essentially, it uses the cone and plate measurement technique to measure your viscosity. What's nice is you can use very small samples. In some cases, just a drop of a pipette, which is very nice. Less cleanup time. It's a little more efficient in that regard. It heats up faster. So if you have to heat your samples to get your viscosity on them to a certain temperature, that can take a little bit of time just because of the amount of sample that you have and the method of heating. Usually it's a water bath you have to put a beaker into. The cone and plate's nice because it has a hot plate directly under it. And so as that plate heats up, it'll heat up your sample, which is usually a small drop of something. And because it's such a small drop, it heats it up very quick, and you can really just throw a piece of sample on there, wait 10 seconds or a minute, and then you have a test ready to go. very fast and efficient. And the screen, I don't know if you can see it, it's pretty small on the presentation slide there, but the screen's identical to our other BYK-Visc, which came out a couple of years ago. So if you know how to use one, you can use them all, which is a nice way to have a lot of products.
Yeah, they are pretty intuitive, and I put links just to the product pages for both the PELT and the Cone and Plate if you're interested. Looking at my list of questions here from our color difference equations presentation. What are the key differences between Delta E94 and Delta E 2000 formulas, and which industries or applications are each preferred?
Ooh, that is a great question. Some of the main differences, I know in Delta E2000, they introduced a curve to the blue region of color space. And for anybody that doesn't know, Delta E2000 is, I believe, one of the newest solid color difference equations for color analysis. And what was different between the 1994 iteration to the 2000 iteration was that they added this equation, or this part in the equation, that essentially turned or shifted the color in the blue section of color space a certain degree, because our eyes don't perceive blues the same way that we perceive all the other colors. Blue is like a special zone. And so with that, it would curve our visual tolerance for each color in the blue region of color space a specific way. And so that's what the 2000 equation does that the 94 equation did not.
Nice.
Really, I typically recommend the 2000 equation to anybody that's doing solid color, just because it's the latest and greatest for solid colors. That's all I have on it. Do you have anything on it, John?
Yeah, no, that's beyond my expertise by far. So no, thank you. Is it, would you recommend that equation, across all industries, or do you know of any industries that specify something different?
Definitely not automotive or any industry that has metallic colors, because then it's a completely different system that you would have to go off of.
Yeah.
But for most solid colors, I want to say specifically it was made in the textile industry. Is that right?
It sounds familiar. I think you're right. Yep.
Okay. Yeah, I think it was originally designed for the textile industry. And I think 94 was developed for, what industry was that? Don't remember off the top of my head, but I want to say Delta 2000 is, like I said, it's the latest and greatest, and it's very efficient at finding color differences for a lot of color spaces. As they went from the original Delta E star, they changed a lot of things about the equations, and every year, or not every year, but each iteration, they would add on another feature to that equation that would make it a little more accurate. And so with that, Delta 2000 is probably one of the most accurate ones out there at this time.
Nice. From our webinar on color measurement tools and uses, can you talk a bit about digital standards and their impact on color harmony?
Yeah, digital standards are great.
Gotta cover those.
So, of course, every time. So what's the difference between a digital and a physical standard? Physical standard is something that you physically have and you can hold it in your hand. What that means for plants or manufacturing is it's a physical thing that could change over time. It also adds in operator error, let's say handling issues. But the real thing is, if you have these physical samples that you're sending to different, let's say, plants, for a good example of this.
Yeah.
All of those plants would be basing their mastered standards off of these physical copies. And the important thing is that these are physical copies, which means you're not always going to have exactly the same data points that one facility is going off of that another facility is going off of. There's small differences that you're not taking into account in there, which could make problems further down the line. An example of this happening would be the case of let's say, plant number 1 has a tile that they're basing their standards off of, and it happens to be slightly higher than, or let's say it's slightly more dark than plant number 2 in their tile. Well, if we think about this and go further down the line and introduce, what is it? Anyway, we go through there. What we find is that, let's say a product was made and now that product is slightly darker than the standard, but it's still within passing tolerance. So that product goes on and gets passed and it's out the door. And then you have plant number 2, which they started with a slightly lighter standard, and they have a product that is, let's say, right on the edge of their tolerance for how light it is. So now we pass these 2 products that passed both of these QC lines, but when they come together at plant number 3, now we're finding that they look completely different. And that's just due to the tolerancing of what the original data points that they're basing everything off of, where they were. Now, if they had something like a digital standard, which is where our products and our software come in, this gets that whole guessing game out of the picture. Now you have one data point or one master standard, and you can digitalize that information and then just email it to anybody who wants it. Like I said, simple email. I could even Teams it to somebody, and then they have the exact same point that I'm basing all my standards off. And so now you're getting everybody exactly, apples to apples, right? There's no longer apples to oranges in this case. Everyone's using the exact same starting point with the exact same metrics and tolerances. So whatever passes at one facility is going to pass at another facility, and so on. And now when you bring all your products, hopefully they're going to match identically. That's
the goal.
Yeah, that's a good example.
Showing those 2 extremes of either end of the tolerances, and then you get it to assembly, and there's a challenge.
Yeah, exactly.
Yeah,
but it's a great resource. A lot of people started to switch over to this, and it's efficient, right? You don't have to put together these tiles and store them somewhere, make sure they're always safe and they're not getting damaged. Now you can just email somebody and forget about it.
Yep. Nice and easy. One more thing on my mind, because I know there's a lot of talk in the industry about Jetness and measuring the blackest of blacks. Can you talk a little bit about that and how we help solve that challenge?
Yeah, so Jetness is a really interesting topic, especially, I don't know if any of you have ever seen it out in real life. It's a very weird type of painting system. When you look at it, normal things, you can see contours, but when you're talking about jet black colors, they absorb all light, and it just looks like a black hole. It's a crazy thing to look at. I recommend, if you're at a computer, maybe Google it. It's pretty cool to look at. But Jetness, one of our instruments we helped develop for this type of weird type of painting system, so we could measure it. Our Spectra 2 Guide Pro. So we helped develop that with one of the, I want to say, the leading pigmentation for jet black pigments. And, we found out a lot of things about Jetness, and they helped teach us about it. At the same time, we were able to produce a piece of equipment that could measure it repeatedly, which I know it's in one of our other presentations for color and appearance. But what Jetness is you have a complete absence of color, which then brings a good point, which is, do we use traditional values like LAB to quantify what Jetness is and where colors are with Jetness? And the answer is no, because when you have such little data going back to that sensor, you can't use normal traditional metrics for that. You have to completely make new ones or use new ones based off of those other metrics.
Yeah.
That's where Jetness indices come into play. So those are just specific values and scales for measuring jet black appearances. And with that, you need a new type of instrumentation. You need something that can shine brighter and for longer, so you have more time to gather more information off of that sample. That's what our Spectra 2 Guide Pro and our Color 2 View Pro do. So they measure in 45-0, so color as we see it, but they have these the special mode called Jetness mode, which you can activate that makes it shine brighter and longer, so it can gather that important data. When you have little to no reflectance coming back, you need to gather more data points in order to understand where you are exactly.
Yeah.
And that's what these instruments are capable of. And it's a pretty cool technology. If you deal in that world, I would definitely recommend looking at it or getting someone out there to give you some demos.
Yeah, it is definitely a different animal than the normal color and appearance measurement. So, yeah, cool tech. Any other questions here? Noah and I can go at this all day for hours, so we won't torture you through it. Doesn't look like any other questions. Again, as soon as I close this, within a couple minutes, you'll receive an automated email with a link to this recording discussion. Feel free to listen to it, share it with colleagues, whatever you like. And I think we're kicking off. I think the first webinar next year. I think it's on color theory, and I believe it's like the 8th or 9th of January. So give you a little time to ease back into it after the holidays. But with that, have a great holiday season. Hope you have a little time off and you can rest and recharge with family and friends. Noah, any parting words from you?
No, just what you said. Everybody take care and have a great holiday. I can't wait to see you back in January. We'll go over some color theory.
Definitely. And I did just flip to the closing slide here. Noah's email address is there. You can jot that down, email him with any questions you have after the fact. Any of the marketing messages, you can hit reply. It comes to my team and we can route it to the right technical specialist. So with that, have a great rest of your day and a great holiday season. Thank you.
Take care, guys.